or a doctor in a hospital. She could be anywhere, in any room, and she is seeing for the first time all the stuff that's in the air she's breathing because there is a sunbeam coming in through the window, which is illuminating the air and giving her the opportunity to see all those particles that are there. And these are particles that contain all kinds of things. They could be viruses, they could be pathogens, they could be smoke, they could be allergens, they could be anything in the air she's breathing. And she's seeing it for the first time simply because it has been illuminated. It is being lit up by that beam of sun coming into the window. And she holds her hand up and she thinks about the fact that she's breathing this air every day that she's indoors. And when we stop and think about the fact that we breathe about 400 cubic feet of air every day, there are some 18 to 20 million particles in every cubic foot of air we breathe, and we spend 90% of our time indoors, it leads you to the realization that we're breathing a lot of stuff into our lungs that we should not be breathing in. And again, it contains everything that's in that air. And she's amazed at that. And what we really need to do when we talk about indoor air quality and engineering air for a cleaner world is clean that sunbeam. We need to get rid of all of the stuff that she sees and can't see because a lot of it is so small, it doesn't even show up when you illuminate it. It's the really small stuff that hangs around in the indoor air indefinitely for extended period of time. It can include viral material such as SARS-CoV-2, which we know can remain in the air indefinitely and can remain infectious for hours at a time. And so the whole idea behind cleaning the indoor air and cleaning indoor environments is simply clean the sunbeam of the stuff in the air. And a friend of mine said this to me most recently, and I thought it was very profound. He said that after 9 months, every citizen has become an expert on asepsis measures. And in order to provide more confidence to, and he said workers, but really it's anybody inside any building. It's for sure this young lady sitting perhaps in her apartment or her office. He said that in order to provide more confidence to all of these people inside buildings, it will be necessary to surprise them with new technologies, things they've never heard of, and most importantly, things that do work and go beyond satisfying the authorities' requirements. And I know here in the United States alone, every year we have a multi-billion-dollar sick building industry where we go into buildings, existing buildings, and we try to clean up the indoor environment of the various issues of concern inside that cause sick buildings. And people know this. And people understand that what we're doing right now isn't necessarily working as effectively as it should be to keep us safe and healthy when we are indoors. So we need to surprise these people with something new. We need to surprise ourselves with something new, something that for sure can work and actually help get rid of the issue of concern, which is all the pollutants in that air that we're seeing in this particular picture. And I'm going to talk about a technology, specifically needlepoint bipolar ionization, that can help do exactly that. And most recently, there was some information that came out of Purdue University here in the United States. Now, if you're not familiar with Purdue University, it is a very prestigious college of engineering, and they have stayed on the forefront of what's going on with regards to, right now, the pandemic, SARS-CoV-2, the virus that causes COVID-19, the disease, and how it is transmitted within buildings. And in November, they ran a webcast called Virus Transmission and Mitigation in Buildings, Past, Present, and Future. And they had an array of experts in the field of indoor air quality and viral transmission and HVAC systems that spoke specifically to this subject. You can see second from the left is Dr. William Blandfeld, who is actually the head of the ASHRAE Epidemic Task Force covering issues with regards to SARS-CoV-2. But in that presentation, Dr. Chin, over here on the far left-hand side, presented new information on studies he had done that talk about effective ways to help remediate the transmission of SARS-CoV-2 in buildings. And he said that to reduce infection risks by 50%, people that enter buildings should wear good fitting masks. And in addition to that, in order to reduce the transmission rate indoors by an additional 20 to 30%, Look at implementing bipolar ionization in the indoor environment, because bipolar ionization can add to the efficiency of existing ventilation and filtration systems and make them more effective. So there's three things that really work when it comes to re-engaging buildings and keeping people inside distanced from the virus itself. Number one, stop sick people at the door. Don't let them in. Take their temperature. Ask them questions. If they've been around someone sick or they're feeling sick or they have a high temperature, turn them away. Don't let them come inside. That's the number one thing you can do. Then, based on Dr. Chin's research, wear a good fitting mask. And on top of that, ionize the space with bipolar ionization. And we'll talk about why that works specifically in the slides to come. Before I go any further, I will say that there are some 250,000 worldwide installations right now of needlepoint bipolar ionization for the reasons that I'll be speaking about in the slides that follow. And to Dr. Chin's point, this is a great way to help buildings re-engage with a population of people who are a little bit nervous about stepping through the front door for the first time. What we're going to talk about is a technology that may surprise them and may make them realize that we've done something different inside that building that may actually work. Some of those 250,000 satisfied installations across the world include various owners you may have heard of: Google, the White House, Harvard, Johns Hopkins Hospital, every single branch of the United States military, the Army, the Air Force, the Navy, the Marines, facilities of theirs. So you're in good company should you consider the implementation of this technology in your buildings or in helping your clients apply it to the buildings that they own and operate right now. So let's talk a little bit about what is ionization. We're going to be talking specifically about bipolar ionization, both positive and negative ionization of the air. Let's talk about what an ion is. An ion is simply an electrically charged molecule or atom in the air that is around us right now. They are imparted there by nature through such various natural occurrences, things like lightning strikes, things like waterfalls and shear interactions with water droplets, that when a water droplet breaks apart, it actually ionizes the air. Plants ionize the air. There's various electromagnetic occurrences in our environment that help ionize the air. And as well, the ionic sphere from way above pushes ions into our environment, the air that we're breathing right now. And where the ion counts are the highest is outdoors where the air is the cleanest. So places like the top of a mountain, places like a seashore where the ocean meets the sand, areas where we go to on vacation to breathe clean air actually are the cleanest. They actually have the most ions in the air based on nature putting them there. Ionization of the air has been called Mother Nature's detergent. It is a way to help clean the air because the atoms and molecules in the air have an electrical charge, positive or negative. They can do certain things from an interaction perspective or from an electrical perspective with various pollutants in the air. And I'll talk about what some of those things are. The problem with ionization is simply this: where nature creates them in abundance, as we work our way inland into more urban environments where we have polluted those environments around us, the ions are diminished in quantity or count as they work to remediate the pollutants of concern in the air, so that by the time they get to the inner city, they are in much lower quantities than where they were outdoors, where the air is the cleanest. In addition to that, when we come inside a building where the air is even dirtier than the air immediately outside that building, the ion concentrations or counts have been diminished even further. So we typically have very, very, very low ion counts in indoor environments, particularly in office buildings and restaurants and schools and hospitals and things of that nature, where typically the inside is polluted by the people and the processes that go on indoors. All we do with needlepoint bipolar ionization inside a building is to impart an artificial charge of ionization, positively and negatively charging the atoms and molecules in the indoor air and delivering those to the space so that the space has a higher ion count, more consistent with the ion count outdoors where the air is the cleanest. Therefore, the indoor air has a better chance at fighting off the pollutants of concern that we're breathing every day. The stuff we see and can't see in that sunbeam that was coming in through the window that young lady was holding her hand up to. We help get rid of those pollutants of concern. And I will talk more about that in the slides that follow. What we do with needlepoint bipolar ionization is simply we impart that electrical ionization of the air directly to the air off of needle points that are exposed to the air off of the device itself. These needle points are made out of carbon fiber material. That is the same material that we make airline fuselages out of, for example. So it is very durable, very robust, very corrosion resistant. It does not wear out or wear down over time, and it is very it's a very great source to energize the air from based on its conductivity, its electrical conductivity. And because of the way that we impart the ions to the air through these needle points, we create an abundance of ionization without creating byproducts of concern such as ozone. Ozone is a serious consideration anytime you have an air cleaning device installed indoors that is electrically powered or has electronic components to it. Ozone is a toxic gas. Ozone is a respiratory irritant. Ozone is not something that we want to bring into healthy environments and emit to the air where people are breathing that air because of those issues of concern. In fact, it's such an issue of concern that ASHRAE, the American Society for Heating and Refrigeration and Air Conditioning Engineers, has specifically said in Standard 62.1, which is ventilation for acceptable indoor air quality, that any manufacturer of electrically powered electronic air cleaning devices shall have their product validated through Underwriters Laboratory for zero ozone production. And needlepoint bipolar ionization by Global Plasma Solutions most certainly does qualify, has passed the validation testing for UL, and does not emit ozone to the air above the concentrations that Underwriters Laboratory allows. It's important when you're comparing any indoor air cleaning technology that you make sure it complies with UL standard 2998 for zero ozone production and ASHRAE standard 62.1, section 5.7.1. So how does ionization work? Well, I mentioned the fact that we are imparting a charge, an electrical charge, to the atoms and the molecules in the air, both positive and negative. What these positively and negatively charged air ions do is work their way out into the space through the HVAC system, and they mix with the pollutants and the particles of concern that are actually in the space itself. And if you think about positive and negative charged particles being similar to magnets, what the ions do that I've charged is they work their way into the atmosphere and they begin to intermix with the various pollutants in the air that also have a charge and perhaps an opposite charge. So my positive ions will attach to a negatively charged particle of some type. Could be a virus, could be a pathogen, could be smoke, could be an allergen. My negatively charged ions will adhere to a positively charged particle. Again, it could be any of those issues of concern. And as they join together electrostatically, they do what's called agglomeration, positive to negative, negative to positive, and pretty soon those really small particles, the ones that are in the air that are so small we can't even see them when they're illuminated by the sunbeam, they become bigger and bigger and bigger through electrostatic attraction with one another, and they now become big enough to be more easily moved. And because they are now bigger, it is easier for a filter to extract them from the airstream and get them out of the air once and for all. And at the end of the day, if the sunbeam is clear, if the issues of concern that I was breathing are no longer in the air for me to breathe, they can't hurt me. And that's probably the number one benefit of needlepoint bipolar ionization. It's actually what we would call clean room technology. It's what we have been using for years in industrial type clean rooms, pharmaceutical, semiconductor, food processing, healthcare, and health laboratory type clean room environments to make them very, very, very clean. We agglomerate the particles, we make them bigger, we move them out of the space with ventilation, we extract them from filters, and they're eliminated from those environments. What we have done with needlepoint bipolar ionization is simply take that industrial clean room technology and we have scaled it to make it both affordable and so that it will fit in more traditional HVAC systems like you have in your home or your office or your schools or your hospitals. And it's a very simple technology to apply that way if you just think about it from that perspective. But because we have imparted energy or electricity to those atoms and molecules in the air that are now in the space, we can do other things from an energy potential. I can actually break apart what's called volatile organic compounds, which are just atoms that are held together electrically. Because I impart ionization energy with my bipolar ionization process, my ions can intermix with these various VOCs, which may be pollutants. Things, for example, like ammonia, which is body odor. It's not necessarily harmful, but it's definitely not pleasant to be around in an indoor environment. Or something as complex as formaldehyde, which is actually an off-gassing of building materials and construction materials, which is carcinogenic. It can cause cancer. But along with some 520 other VOCs of concern, I can interact with those VOCs that are in the air that we're breathing in the space, and I can break them apart into their individual constituents, down to their individual elements that then regroup in the atmosphere in a safe, desirable, and perhaps already prevalent entity in our air, such as nitrogen gas or H2O. In addition, because I've imparted an energy potential to the atoms and molecules through the ionization process, I can also inactivate viruses of concern, specifically SARS-CoV-2, for example. When we look at the anatomy of a SARS-CoV-2 virus, what we have is an RNA material, which is the genetic makeup of the virus itself. That's what can make us sick when we inhale that virus. And it is encased in a fatty lipid membrane that consists of proteins. And to that protein membrane are binding spikes that are also a protein substance. These binding sites that you see on the top of the virus are what will actually attach themselves to our cells when we breathe them in and they get deep into our respiratory system. And although a virus isn't living, it can't replicate on its own. It needs a host to attach itself to and infect, and then it takes over our cells and it makes us sick or it kills us. And even though it isn't living, what I can do is inactivate it. And the way it works is simply in very similar form to the electrostatic attraction that I talked about earlier on other particles. We know that the SARS-CoV-2 virus has a net positive charge that's imparted to it by nature. What I do is allow my negatively charged ions to intermix with the positively charged viral material and electrostatically attract or agglomerate to it. At that point, a chemical reaction occurs on the surface of the virus and in the protein spikes that attach themselves to our cells. And it breaks down those proteins and it renders that virus incapable of infectivity. And in fact, needlepoint bipolar ionization by Global Plasma Solutions has been specifically tested on SARS-CoV-2 virus, the virus that causes the disease COVID-19, and it has been shown under third-party laboratory testing to have a rate of reduction of 99.8% in 30 minutes. If you look below, there are a list, a broad array of other pathogens and viral issues of concern that this technology has been proven effective on. You'll see tuberculosis and MRSA and staph and E. coli and norovirus and Legionella. Here's human coronavirus strain 299E or CoV-1. That is what most competitors, when they are talking about their product and comparing it to ours, will say they can inactivate it. They will not specifically claim efficacy on SARS-CoV-2 because they haven't tested it. What they've tested on, as have we, is coronavirus 1. And while they do have efficacy on human coronavirus, this particular strain, They have not tested to the mutated strain of SARS-CoV-2. They therefore cannot be assured that, or nor can they assure you that they can inactivate it. So if SARS-CoV-2 is your issue of concern, make sure that you're dealing with a credible air cleaning manufacturer, such as ourselves, that have proof of efficacy through laboratory testing that they can give you specific to the virus that you're most concerned about in the indoor space. Now, I'll give us a simple example of how this system might look in the real world. This is a crude rendition on my part. I apologize, but it's the best I can do. On the left-hand side, we will see a space, an indoor space. I'll come back to that in just a minute. On the right-hand side, we see a typical HVAC system that might be installed in a building. It would consist of ductwork. It would consist of hopefully an air filter to help extract particles that can get back to it from the space. Perhaps heating and cooling coils, perhaps humidification. I've shown that we've installed needlepoint bipolar ionization within the system as our air cleaning technology of choice. We have more ductwork and a fan, and of course we pull air from the space. We attempt to filter it. We heat it, we cool it, we humidify it. We try to treat it with some type of an air cleaning technology. And then we send that air back to the space, tempered, conditioned, and hopefully cleaned to help create safer and healthier environments. Now, on the other hand, we have a space that has all these issues of concern: viruses, VOCs, pathogens, allergens, smoke odors, dust particulate, etc. And we know that some of this is so small that it will remain in the environment indefinitely. And unless you install an HVAC technology in the air handling or HVAC system itself that can reach out into the space and begin actively treating these issues of concern, you will not be effective at remediating them from the space. So let me show you how needlepoint bipolar ionization works. I impart a charge of ionization to the airstream. These ions then flow through the ductwork out into the space itself, and they begin working on the issues and deactivating those issues, actively treating the space immediately. So I begin inactivating viruses. I begin breaking apart VOCs. I begin killing pathogens, things like mold spores and bacteria and fungus, other microbial issues of concern that might be in the air on surfaces in the space itself. And then I begin agglomerating those, making them bigger, along with everything else that's in the air. And I agglomerate it to the point where, even though it was too small to influence with air motion at one time and to get out of the space, it's now large enough that I can influence it. And because it's larger and can get back to the HVAC system, filters are more effective, and they can extract that material from the air and get it out of the air we breathe once and for all. It's a technology that can clear the sunbeam of the stuff we see and can't see. And anything that gets through the filter can now be treated by the air cleaning device that I've installed inside the system. And I continue to circulate the air in that manner until I actively treat the air and surfaces just like I would in a clean room, an industrial type clean room, and I get everything out of the air and back to the system and extract it from the airstream once and for all. There's a variety of component or HVAC system types and locations that needlepoint bipolar ionization can be installed. On the left-hand side, we see a building with some of the various location options for the equipment itself. If we start on the roof of that building, we can see that it might be installed in a large air handling system or a large rooftop system, either on the roof or somewhere in the building itself. I can install it as I work my way down the ductwork in various terminal unit devices such as fan coils, our blower coils, our VAV boxes, or mini split air conditioning or VRF systems actually within the space itself. And as well as if I move over onto the right-hand side of this drawing, I can actually install the technology as close to the space as I can get it so that I get the most ions to the space. I get them delivered as quickly and as efficiently as possible so that they can begin remediating the issues of concern and the contaminants in the space, some of which may be specifically SARS-CoV-2 viral material. So I can install it in the ductwork immediately adjacent to the space, or I could wheel in a device such as Carrier's OptiClean, which is a portable HEPA filtration unit. That unit actually has a HEPA, H-E-P-A, high efficiency particulate arrestance filter installed in it, which is 99.97% efficient. I can add ionization to that device, which flushes the space with ionization to begin actively treating the space and remediating and inactivating and killing the issues of concern in the space, as well as agglomerating them and now pulling them back to a filter that's 99.97% efficient. And this system itself, this particular application, may be the ultimate way to go about cleaning indoor environments if it's something that you can apply to your particular buildings. This is just a picture of how it might install inside a unit such as the OptiClean. You can see on the bottom the high efficiency 99.9% efficient filter, and then this needlepoint bipolar air ionization device would simply attach to the fan scroll, and then it would emit ions into the space directly through the discharge of this unit, and then return air from the space to the bottom to be filtered and ionized again over and over and over until I actively treat those issues, remove them, and create a clean room type environment in more traditional applications, again, such as offices and schools and hospitals and things of that nature. And with that, I would like to say thank you and open it up to our hosts, if you will, for any questions that may have come in.
Well, thank you, David, for your presentations. A very interesting topic you're talking about. Now, this moment, we're going to start with the question. En este momento, entonces, invitamos a la gente a comenzar a formular sus preguntas. Pueden formularlas en inglés o en español en la pestaña de Discuss que tiene en el costado derecho de esta plataforma. Entonces, los invitamos para que a partir de este momento formulen sus inquietudes. Ya tenemos una pregunta. Ricardo, ¿estás ahí también?
Aquí estoy, Duan, gracias.
Muchas gracias, Ricardo. Bueno, entonces, como les comentamos, Ricardo nos va a apoyar también ahí con la traducción para David. Ricardo, la primera pregunta la tenemos, está un poquito amplia, voy a leerla muy despacio. De hecho, también tienes acceso a ella ahí si le das clic en Discuss a la pregunta. La pregunta es de Alejandro Hernández. ¿Cuál es la densidad de iones positivos y negativos por centímetro cuadrado que necesitamos obtener en un espacio interior para asegurarnos de que estamos combatiendo el virus como el coronavirus?
Perfecto.
Primero esa primera parte porque hay dos preguntas de él.
Empezamos con eso. Gracias, Duan, y gracias, Alejandro, y a toda la audiencia por sus preguntas. Aquí estamos para responderlas. Se la voy a traducir a David. Dave, so there's a very interesting question, and it goes like this. What is the concentration of positive and negative ions per cubic centimeter or per cubic feet that is needed in an indoor space in order to guarantee or in order to, effectively battle SARS-CoV-2?
It's difficult to say exactly what would be required from an ion concentration in the indoor space to be able to remediate any issue of concern without knowing how much of that viral material, for example, is in the space. Typically, what we try to do is create an environment that has been ionized to a level that is consistent with the outdoor air, where the air is more cleaner. So we try to replicate clean outdoor air based on its ion count indoors.
Perfect. Básicamente lo que nos dice David, Duan también para obviamente traducir la respuesta, es que es difícil hablar de una concentración específica o algo cuantificable sin conocer, digamos, la cantidad o la carga viral o la concentración de cuánto virus puede haber en ese espacio, pero que típicamente lo que se busca con la implementación de tecnologías como la ionización bipolar y en el criterio de David es buscar que el nivel de iones, el nivel de ionización que se obtenga en el espacio interior sea consistente o sea equiparable al nivel o a las concentraciones de iones que se tienen en espacios exteriores que típicamente tienen, digamos, una calidad de aire superior a lo que se ve en espacios interiores.
Excelente, Ricardo, muchas gracias. La segunda parte de la pregunta que hace Alejandro Hernández es ¿dónde se puede obtener un white paper que describa qué es la densidad adecuada para eliminar virus? cuál es la densidad adecuada.
Do you have any reference, David, of a white paper or some, reliable reference that talks about, this topic of the concentration of or the density of ions and its effectiveness on different types of viruses?
We do, and I'd be happy to forward that on if I can get a point of contact to give that information to, and then you as well can feel free to forward that on to anyone else that might like to have it.
Fantastic. Duan, simplemente que nos pasen la información de contacto y con mucho gusto yo les hago llegar unas referencias que sí tiene David en sus manos.
Vale, podemos invitarlos incluso a que participe o que ingrese al booth de Carrier, que van a estar disponibles todo este resto del día, que Alejandro entonces le pedimos también que ingrese y ahí pueden contactarlos con ustedes y los pondrían en contacto con David para que reciba la información. También ahí Alejandro nos compartió el correo electrónico, Ricardo, ahí en el panel de Discuss, entonces si también lo puedes tener referenciado, sería muy interesante. Otra pregunta de Jorge Gaitán, esta está en inglés. David, I have a question, says Jorge Gaitán. Would you recommend bipolar ionization over UVC light? If so, why?
I think the big advantage that needlepoint bipolar ionization has over a UVC light system that has been installed inside the air handling unit is simply that bipolar ionization can reach out into the space through the ductwork as the ionization is delivered to the space and begin actively treating the pollutants of concern there, instead of waiting for them to get back to the HVAC system like a UVC light system would require in order to be effective.
Sí, para traducir es un poco, Duan, la respuesta de David habla que una de las razones principales por las cuales en su criterio recomienda la ionización bipolar sobre las lámparas ultravioleta es debido a que la tecnología de ionización bipolar digamos que puede ser más activa en el sentido que puede entrar al espacio y actuar en el espacio, ¿cierto? Atacando los... Ok, y lo que estaba diciendo es que la ionización bipolar...
David, you have a noise at this moment. Can you check your microphone? Disculpa por este momento, estamos pidiéndole a David si puede solucionar el ruido de su micrófono. David, can you hear us?
Ok, creo que mejoró.
Sí.
Bueno, entonces les estaba diciendo que la ionización bipolar, la gran ventaja que tiene sobre las lámparas ultravioletas, digamos esa propiedad de que los iones son liberados a la corriente de aire, pueden entrar al espacio, pueden actuar, pueden atacar los patógenos que estén suspendidos en el aire y digamos que no existe esa necesidad o esa limitación que tienen las lámparas ultravioleta en el sentido de que tienen que, cierto, esperar dentro del sistema de aire acondicionado, dentro de una manejadora de aire, a que el aire regrese para poder actuar sobre esa corriente de aire, ¿no? Esa es la ventaja principal a la que hacía referencia David en su respuesta.
Muy bien. Otra pregunta de Alejandro. Alejandro, muchas gracias, muy participativo, excelente. Hay fabricantes de ionizadores unipolares que dicen que los iones positivos causan cáncer. ¿Eso es cierto?
David, can you still hear us? David, can you still hear us?
Creo que se nos fue David.
Creo que se nos fue. Yo con mucho gusto ya con la información de Alejandro le puedo compartir más información acerca de esto. Lo que sí pudiese compartir, y de pronto no es una respuesta directamente a esa pregunta, pero sí expresarles que la tecnología de ionización bipolar de Global Plasma Solutions, que de hecho tenemos una alianza global con Carrier.
Importante mencionar eso, sí.
Para comercializar esto, cuenta con todas las certificaciones de seguridad, ¿cierto? Todo lo que es seguridad ocupacional, certificaciones UL que van muy dirigidas a la parte de no generación de ozono y nada que pueda generar algún tipo de impacto en el sistema respiratorio del ocupante. Contamos con todos ese tipo de certificaciones para que todos los usuarios a nivel mundial que decidan instalar este tipo de tecnologías tengan la tranquilidad de que hay laboratorios prestigiosos de terceros que certifican que no tiene ningún impacto negativo en la salud de los ocupantes, no genera ozono. Y bueno, específicamente a la relación con los iones positivos, le voy a pedir el favor a Alejandro que nos dé la oportunidad de contactarlo vía correo electrónico para darle más información, pero que se quede tranquilo que a nivel de seguridad ocupacional se cuenta con todas las certificaciones del caso.
Gracias, Ricardo. Entonces te comprometemos ahí, ya tienes el correo a la mano de Alejandro para que también generen esta interacción y invitamos a Alejandro a que también los visite ahí en el booth. Ricardo, cuéntanos un poquito cómo ha sido esa adopción, si ya la hay en América Latina, de estas soluciones conjuntas entre las soluciones o las tecnologías que provee Carrier y ahora pues con estas, digamos, valor agregado del tema de la ionización. En América Latina ya han hecho cositas, ya han hecho algo. ¿Cómo ha sido ese proceso?
Bastante, Duván. Gracias por tu pregunta. Cuando comenzó la pandemia, febrero, marzo, inmediatamente en Carrier, al más alto nivel, desde el punto de vista de corporativo, se activó todo un plan de desarrollo de tecnología y de poder llevarle a nuestros clientes soluciones que pudieran permitirles atacar toda esta temática de la calidad de aire interior, ¿cierto? Una de las cosas, de las primeras cosas que se hizo fue desarrollar una tecnología que se llama el OptiClean. David lo mencionó, que es básicamente un filtro HEPA portátil, es una solución que las estamos utilizando mucho, Duan, a tu pregunta, en dos tipos de aplicaciones en Latinoamérica, que es obviamente en espacios hospitalarios que empezaron a agotarse los cuartos de aislamiento en ese tipo de aplicaciones en hospitales. Entonces, esta tecnología del OptiClean te permite venir y convertir espacios de encamados o espacios que están en presión positiva en un hospital, convertirlos a presión negativa, ¿sí? Que es el tipo de presurización que tú quieres cuando quieres poner un paciente que lo quieres aislar porque tenga una enfermedad infecciosa como es el caso del COVID-19, ¿no? Entonces, hemos tenido mucho éxito con el OptiClean en ese tipo de aplicaciones, pero también hemos visto una demanda alta para esta máquina en una aplicación que no tiene nada que ver con presurización, sino que es simplemente como un purificador de aire portátil que tú lo puedas ingresar en colegios, por ejemplo. En los colegios hemos visto mucha demanda de los OptiCleans, oficinas, sí, por más de que hay mucho teletrabajo, hay empresas que están tomando medidas en Latinoamérica para poder transmitirle confianza a sus empleados al momento de que decidan regresar a la oficina de manera parcial o de manera total. Entonces han hecho bastantes empresas, específicamente en Centroamérica, inversiones fuertes en depuradores de aire portátiles como el OptiClean. Y lo mismo que te acabo de explicar, también hemos visto mucho con los ionizadores bipolares, particularmente en el Caribe, en República Dominicana, hemos visto un aumento gigantesco en la demanda de lo que es ionización bipolar. Entonces, definitivamente, Duvana, tu respuesta no solamente de cositas, hemos visto un gran aumento de actividad y ha sido una de las mejores noticias en cuanto a venta de equipos y de soluciones que hemos podido llevar al mercado. Para Carrier, definitivamente ambas soluciones, el OptiClean y la ionización, nos han traído muy buenos resultados este año.
Qué bueno, y qué buena también esa reacción del usuario final por preocuparse, por renovar sus espacios, por cuidarlos y por implementar la más reciente tecnología que ustedes tienen. Ese OptiClean también ganó un premio hace poquito, Ricardo.
Gracias, Duan. Sí, la revista Time le acaba de dar un reconocimiento como una de las invenciones más importantes del 2020 y bueno, estamos muy orgullosos, queremos seguir llevando esto al mercado y que los clientes lo sigan utilizando en sus edificios para que le brindemos un aire de mejor calidad a los ocupantes.
Claro que sí, Ricardo. Pues muchísimas gracias por tu participación, por acompañarnos en este espacio de Lake Control Summit. Muy interesante todo lo que vimos a través de David también. David, can you hear us?
Can you hear me?
Yeah, now we can hear you. David, thank you so much for your time.
Thank you. I apologize for the issues with the sound, but I truly appreciate the opportunity to be here with all of you today. Thank you so much.
Thank you for joining us. Ricardo, muchísimas gracias.
A ti, Duan, muchas gracias a todos los organizadores del evento y bueno, los invitamos a que pasen por el booth de Carrier si tienen alguna otra pregunta. Muchísimas gracias a todos.
Claro que sí, a nuestros asistentes muchas gracias también. A partir de este momento y durante los próximos 45 minutos, 12:30 hora de Colombia, 11:30 hora de Ciudad de México, pueden participar en los booths. Los invitamos a que vayan, hagan clic en la pestaña de Floor que ven en la parte izquierda de su pantalla. Ahí van a encontrar los booths que están participando en este espacio. Pues vamos a invitarlos a que vayan al booth de Carrier, también el de Cochillers, el de Lennox, y participen y generen también una interacción bien interesante con nuestros expositores. Recuerden también, ahí en el lobby pueden escribir desde dónde están participando, de dónde vienen, de qué países nos escriben. Sería muy interesante también conocerlos para saber cómo ha sido esta actividad para ustedes y la experiencia. Entonces ya saben, volvemos a las 12:30 minutos hora de Colombia, 11:30 hora de México para la tercera exposición del día, que les comento de una vez cuál será: limpieza y desinfección ACR para ambientes sanos. Una conferencia también muy interesante con varias recomendaciones ahí para este tipo de soluciones. Entonces les agradecemos a todos y nos vemos entonces en 45 minutos en la próxima charla, pero no se desconecten para que sigan participando acá en el espacio de A Control Summit. Muchas gracias.